The Gulf Coast is experiencing significant growth and expanded economic development, but it takes a team of people to help build that infrastructure. Today we're going to look into a program that is helping support this movement with the University of South Alabama's Civil Engineering Department. That and more, all this week on The Job.
Civil engineering is very essential to the planning, designing, and construction of all types of infrastructures. This is because civil engineering focuses on the public and environmental health of where an infrastructure will be constructed. They deal with important issues like air pollution, groundwater and waste disposal, and flooding and erosion issues that could arise from construction in a particular area or with particular materials. At the University of South Alabama, the Civil Engineering Department has been training their students not only in the career of becoming a civil engineer, but they have also been proactively involved with real-life situations happening in their community. We visited the campus and met with Dr. Kevin White.
Dr. White, what is civil engineering?
Well, civil engineering is probably the oldest engineering profession, and what we do is design society's infrastructure. Structural elements like skyscrapers and buildings and their foundations, environmental engineering that deals with drinking water, wastewater, water resources and coastal engineering, ports, transportation engineering, roadways, bridges, etc. So it's a pretty broad engineering discipline that handles our society's infrastructure.
And without infrastructure, you have nothing.
Right, we couldn't function without the things that we design and build.
Why is civil engineering important to Mobile and Baldwin counties?
Well, we have to have the civil engineering infrastructure to be a urbanized society. And we have a lot of industries and businesses in the Mobile area that rely on civil engineering and our graduates, people like the U.S. Army Corps of Engineers who build structures all over the world. A city such as Mobile that has 300,000 plus people, we need ways to get around and move. We need drinking water, we need wastewater management, solid waste management. We need structures to live in, particularly structures that can withstand things like hurricanes that we get here along the Gulf Coast.
Well, you have so many factors that affect your research, I'm sure.
Absolutely, and being in this area, in the northern Gulf Coast area, there's some interesting aspects of civil engineering that we have to deal with. High wind loads from hurricanes, a lot of water and waves and storm surges, particularly during storms, high groundwater table areas that we have to maneuver around or utilize for our drinking waters. So there's some unique aspects in the southern part of the state that are very much interesting, and our research tends to focus on those areas.
And speaking of research, Dr. White, what can students brush up on when it comes to their study before they enroll in a program such as SOUTH's?
Well, number one, we have a fair amount of undergraduate research opportunities as well as graduate research opportunities. Number two, to get into engineering, you really need to have a background in both science and mathematics. So if you're a high school student and you want to go into engineering and solve all kinds of problems and come up with unique solutions, it's a very rewarding career. You need to really focus on those math classes and science classes, physics in particular, algebra, trigonometry, and calculus.
And from your personal experience, why is civil engineering a rewarding career?
Well, we build a lot of large projects that we know the public is going to utilize. And it's very rewarding to sit down, figure out the solutions to a very complex real-world problem, and then see it constructed and utilized by virtually everybody.
The students enrolled in the Civil Engineering Department at the University of South Alabama are privileged to work on projects that reflect and affect their current surroundings, which are projects that deal with the coastal region. So we were introduced to Chris Marr, a grad student who showed us their wave basin laboratory.
Well, wow. What is this?
What you're standing in right now is the University of South Alabama's wave basin. This is a part of the civil engineering department here. What it is basically like an indoor wave pool that you might see at a water park. There's a bulkhead back here that can create and push the water through and create the waves. We have a sandy beach here to simulate beach in a natural environment. And this is the laboratory that we use to run different experiments on different engineering structures.
Well, Chris, since we're located in the Gulf Coast, I guess this type of research is important.
Very important. You know, as civil engineers, we're very interested in both the laboratory and the real world. The laboratory is kind of an area that we can control the environment and set everything up for a specific, specific scenario so that we can test in different environments on how things are going to run. The important thing about here is that, like I said, since we're on the coast, we can simulate a coast essentially. You know, we have a sandy beach here, we have the water, we can create the waves. We can run different kind of tests in here. One of the first tests we'll see is here. These are what we call wave attenuation devices. And these are actually a scaled down model of something that's being used out in the real world right now. And what these basically do is the purpose of them is to try to cut down the amount of wave energy that transmits across them. And by the main purpose of that is they're going to cut down the amount of wave height. These specific models are being used for a project that's located near Bayou La Battery, Alabama, down on the Gulf Coast. They set these up out in the water. The real models that they have out there are about 5 feet tall, as opposed to these are about 1 foot tall. And like I said, the point of them is to cut down the wave height and to cut down the amount of wave energy that's hitting the coast and causing erosion and different problems like that. The tests that we can run in here, we have these what they call wave gauges. They're 2-wire wave gauges, and they can measure the wave height. Where basically, once we start the waves, we can measure what the wave height was in front of the structure and then measure the wave height behind the structure here. And by doing that, we can come up with what they call a transmission coefficient that's going to be able to tell how much of a wave reduction or wave height reduction that we have.
Well, I'm sure with waves, I mean, just the ocean floor, everything changes when you have a structure out there, I'm sure.
Very much. That's kind of one of the things about the laboratory. Like I said, we can't control the environment, but it's kind of tough to necessarily recreate the exact environment that you're going to see out there.
I mean, I see water and sand and everything. I mean, you guys have really created the environment here.
Mm-hmm. And like I said, the best thing about this is that before that they spend a lot of money on these projects and implementing them out into the real world, is that we're able to kind of see exactly how effective they are.
Simulations like these are used to study different situations that can potentially happen in real life. Civil engineers can take the information from these studies and apply them to real-life applications to alleviate potential problems in the future, such as the destruction of bridges during a hurricane.
What we're going to do now is we're going to show you another test, another demonstration that we run in here. It's basically showing exactly what happened during the recent hurricanes that destroyed a lot of bridges along the Gulf Coast. This is a scaled down model of a bridge, an interstate bridge deck or a road bridge deck that you might see here and along the Gulf Coast. It's set down on these pilings. And what we're basically going to do is that we've simulated a water depth that matches generally what you would see in a storm surge, or what we did see in recent storm surges or hurricanes. And we're going to turn the bulkhead back on here and create some waves that are similar to what you saw during a hurricane wave, and then kind of see exactly what's happening as the bridge is getting knocked off the bridge deck. And the good thing about this is that we're able to kind of, during a hurricane you can't necessarily be standing out on the bridge and be watching it fall over and seeing what's going on. So, as I said before, in here we're able to kind of recreate a scenario that you might see during that hurricane or during the storm. And we can kind of test and watch on what exactly is happening as the bridge is getting knocked off. And so we can, as engineers, we're very interested in, one, why did these bridges fail? Why did they fall into the water like they did? And two, how can we better design them in the future so that we don't have that problem and we save a lot of money?
Well, Chris, is the idea, I guess, more or less, is it for the water to come over the bridge and knock the bridge over? I mean, will the water just kind of come and just be right there? Or, I mean, what's the idea, more or less?
What you're basically going to see is that as the waves come in, they're going to be crashing against the side, and as the bridge deck begins to be submerged, a bridge is no different than anything else. It's going to have a buoyant force on it. It's going to lift it up a little bit. It's going to want to float even just a little bit. And just by that, the waves are strong enough. They actually can sit there and knock it all the way over, even a huge bridge deck that you might see on a road in the real world. And so this is just kind of a scaled down demonstration where you can kind of see exactly what's going on there.
Okay, perfect. Let's do it.
So we'll get Dr. Webb in here to turn some waves on for us.
All right. Well, now these waves are a little bigger, Chris.
These are a little bit bigger. Like I said, these are kind of trying to simulate a hurricane storm surge wave that you might see. You can see it's beginning to kind of get knocked and scooted a little bit. And what we kind of learned is that as the water depth continues to raise and the storm surge get higher and higher, that eventually it's going to scoot and scoot and scoot until eventually it's just going to get flipped over and knocked off the bridge. The water may not be touching right now.
Is the idea to knock the bridge off?
Well, I mean, not in the real world, obviously, but here in the laboratory, that's what we're interested in. We want to go through and recreate different scenarios that happen during the hurricane, so we can see, at what point does the bridge get knocked off? At how deep does the water need to be? How big do the waves need to be before the bridge gets knocked off?
And even though this is a simulation, Chris, are you able to take this data and apply it to, I guess, real world applications to understand, you know what? In real life, this wind would be 50 miles an hour or whatever.
Right. It is just a simulation, but you can definitely take that knowledge because you can kind of get an idea. You're sitting here watching, seeing exactly what's happening as it's going on. There's different sensors that we have that we can hook up to there that kind of tell where the forces are acting on that bridge and kind of how that bridge is wanting to move. So you can kind of see where the weak points are on it. And one of the main things that we're most interested in here is exactly how high up does it need to be above the water before we have an issue with the waves actually hitting it.
Well, I can tell you one thing, Chris. You and your staff and the rest of your fellow students here are definitely on top of it when it comes to this study and research. And I appreciate you allowing me to come out here and be a part of it.
Well, thank you, Bobby. Thanks for having me.
Thank you so much, Chris.
There's more to the civil engineering program at the University of South Alabama. But first, let's take a look at this week's job and training opportunities.
And now, let's power up your career with this week's Alabama Power job and training opportunities. All of these opportunities are for pre-employment training through AIDT, unless otherwise stated. In Chambers County, Augene USA is seeking production candidates for its metal stamping facility in Cusseta. Augene is a Tier 1 supplier of automotive parts to Kia Motors Manufacturing of Georgia. A high school diploma or GED is required, and previous experience in the automotive industry is preferred but not required. Wages will start at $10 per hour plus benefits, with progression to top rates. In Pike County, CGI is seeking collections and other professionals for its Troy facility. Interested candidates must apply online at www.aidt.edu/jobs or www.cgi.com/careers. CGI is also hosting a job fair on April 29th from 3 until 9 p.m. at the Troy Municipal Airport. In Tuscaloosa County, Forcia is seeking production assembly operators for its automotive seating plant in Cottondale. Starting wages will range from $12 to $13 per hour. A high school diploma or GED is required, plus 1 to 2 years of manufacturing experience is preferred. Forcia is also seeking team leaders, with starting wages ranging from $12 to $14 per hour. Deadline for applications is April 16th. In St. Clair County, WKW Automotive is seeking applicants for a pre-employment program for its new facility in Pell City. Selected candidates may be trained in anodizing, assembly, mechanical machine operating, quality inspection, and polishing. All positions require a high school diploma or GED and start at $9 per hour, except for polishers, which start at $11 per hour. In Butler County, Hisco America Company is seeking production team members for its Greenville operations. Hisco provides coil processing, just-in-time warehousing, and delivery service to the automotive industry. Candidates must have a high school diploma or GED and be at least 18 years old. Candidates must be able to work either first or second shifts and to work scheduled overtime as needed to meet customer needs. Wages will start at $9 per hour and up. If you applied prior to February 27, 2011 with Hisco, you must reapply to be considered. That's a brief look at some of the training and career opportunities available this week on the job. For more information on these and other opportunities, visit our website at www.onthejobtv.org.
The Civil Engineering program at the University of South Alabama touches on several different aspects of engineering, and one of those is environmental engineering. Dr. Andy Welton is the Assistant Professor of Environmental Engineering and explains one of the studies of the department, drinking water treatment.
Dr. Welton, tell me about your research and study.
Well, here at the University of South Alabama, we have an environmental engineering laboratory, and that's what we're in today. The research that I'm involved with is drinking water treatment, so basically helping the utilities around the country and the world identify methods to treat their drinking water better, to remove chemicals so that they don't reach the customers that are drinking water.
I guess, being here in the Gulf Coast, this type of research would be pretty important.
Very, very important. This research is focused here on the Gulf Coast, but it is truly a worldwide problem. With regards to the drinking water, chemicals that are in the Gulf Coast water, those are the same chemicals and compounds that are in the water in Iowa, that are in the water in Washington State, Asia, as well as Africa.
One of the students of the Civil Engineering program was there to demonstrate some of the tasks involved with the environmental engineering aspect of the program.
Yes, sir. What we did was we started with a dirty water, if you will, in all these jars. Like Dr. Welton said, this is a jar test. These are individual jars. And what I've done is I've taken our alum, which is aluminum sulfate, and I've put it in each jar at a different dosage. And I didn't put any in this jar to show you as our control, and then what I did is I upped the dosage for each jar. And while I did that, we had the machine at a fast RPM to get a rapid mix. And now what we've done is we've turned it down to a very slow churn. And what that's going to do is allow the chemical to interact with this water to flocculate all the particles together. And it's going to basically take these individual particles that make dirty water, now it's going to collect them together, and then they're going to settle out down at the bottom. And what you would see over time is you would see this one stay the same at dirty, and these would intermittently come down and get more clear.
Well, it's almost like a timeline here, Bennett, because I'm looking, this container does look dirty. This one, yeah, but it starts getting even just more and more clear as we go down the line.
Yes, sir, that's correct.
And I guess, and that's our goal.
Yes, sir, it is. And then we can get the proper dosage to the water per different waters that we have. And then that way, when we go to design the drinking water plant, we know what doses to add to get the optimum levels of clear water.
And tell me about some of the compounds that you were pouring into the water. That I saw you over here with the Pyrex dish, and you were doing a lot of different things.
Yes, sir. What we did was we took aluminum sulfate and we diluted it into water at a certain concentration, and then from there I took the pipette and pipetted certain concentrations into each jar of the alum. And alum you can get in your parents' cabinet. The McCormick makes it. It's a little container. It says alum wrote on the side of it. And what we do is we mix it in with the water, get it to a right concentration, and then as you can see, we'll move it. And over time, you'll see these start to clear up from our test to our extreme clear.
And you wouldn't recommend me to drink that either, would you?
Not in the current state, I wouldn't.
I understand. But you are improving it more than the way you found it. It looks
yes,
like.
Sir. Yes, sir.
So when you were looking for civil engineering schools, what drew you to South Alabama?
What drew me to South Alabama was the quality of the College of Engineering, but also the size of the College of Engineering. My hometown maybe has 3 traffic lights in it, and so going to a massive university scared me, but I wanted the same quality of education. And being all the way in North Georgia, my parents' house away from here is 9 hours, I still heard about the University of South Alabama. and I love the classroom sizes, and I just immediately fell in love with the institution. It's a great college, and I love it.
A successful civil engineering student is one that is passionate about learning. They may not know how to learn until junior or senior year in college, but it's when the light bulb turns on and they realize that what they're doing and learning about is actually going to change lives when they graduate. That's what makes a successful civil engineering student.
So, we've looked at the study of waves created by hurricanes and the effects that can take place. And we've looked at the water that we drink and how it's processed. Our final stop was at Dog River with Dr. Brett Webb. He has constructed something very interesting which helps collect specific data on large bodies of water.
Well, Dr. Webb, we're here at Dog River, and I'm all dressed out and everything, and it looks like we have a jet ski, but I think you called it a jag ski.
Yeah, Jag Ski was the name that was given to it to sort of fit with the University of South Alabama Jaguar theme and mascot. And what we've got here is a 3-person personal watercraft. It's a 2008 Kawasaki model. And we've put a number of pieces of equipment on here that we can use to measure certain things about the movement and the characteristics of the water.
Interesting. So I guess we're going to try to see how that works today, right?
That's the plan anyways. It looks like everything's on and everything's working. And so the idea will be to go out here and collect 2 types of data today, really using or showcasing the 2 pieces of equipment that we have on here.
Now, why is this research important?
For a number of reasons. This really became most relevant during the recent oil spill, and that's really the emphasis behind this new piece of equipment on the back, which is a YSI portable seakeeper. And what this does is got 2 different sensors inside. It collects near surface sample of water continuously as we drive along, and it's got a crude and refined oil, or crude oil and a refined fuel sensor inside that allows us to measure the relative concentrations of those things at the surface. So the idea was to have this piece of equipment operational during the oil spill, and it just so happened that after we actually submitted this proposal to National Science Foundation, the next day the well was capped. And so they decided to follow through with it and said, you know what, this is still going to actually end up having a positive impact in terms of research efforts, and so we're continuing to use it in the Bay and also in places like Dog River.
Do firms out in the real world, do they use equipment like this?
Generally, they don't have the in-house capabilities to have something this sophisticated. They would subcontract out to a specialized firm, or maybe even to their local academic institution like the University of South Alabama.
So what you're telling me, Dr. Webb, is this equipment has more or less changed the game for your program?
Yeah, and it's actually funny that you would say that word, because when I came back after operating this system for the first time, I was telling my colleagues that this is truly a game changer.
And it is.
Yeah, it really is.
Can you walk through some of the pieces of equipment for me just to let me know kind of what everything does and how it works?
Absolutely. The first thing we have here is this little white unit right here, and this is called an acoustic Doppler current profiler. And this has 9 beams. One of them is a vertical beam that allows us to measure the depth of the water. And then the other 8 beams are used, and they have different frequencies, and they jump between the frequencies depending on how deep the water that you're in. And so the instrument already knows and has pre-programmed into it this sort of frequency hopping algorithm. So if you're in really shallow water, it's going to use a high frequency signal, and if you're in deeper water, it'll use a low frequency signal to measure not only the depth but also the water velocities. And so what this instrument does is allows us to create more or less a 3D picture of what the water column looks like, how the water's moving, where it's moving, and how fast it's moving.
Because the bottom line is we can't see what's in that water.
That's right.
We just can't. However, with the Jag ski, changes everything.
Yes, absolutely. So we can see how fast the water's moving at the bottom relative to the surface, or vice versa, or how fast it's moving on one side of the river or the other, one side of the bay or the other.
And you need to know that if you're building a bridge, or if you have a building out there, or even oil, or whatever it is.
Yeah, and also just in terms of general circulation of the bay or for a river, it's very important to understand this information, because it allows you to estimate or characterize how water is exchanged between different bodies of water. And that could be important not only for pollutants, but also for sediment transport. So that goes a long way in determining how healthy our beaches are. So how is sediment moving in and out of the bay, communicating with the Gulf of Mexico, but also biological material. Not only harmful algal blooms, how they might move in and out from the Gulf of Mexico to Mobile Bay, but also how larvae and post-larvae might be lost from Mobile Bay to the Gulf of Mexico, or vice versa.
Wow, so this has really embarked, the department to gain a whole different perspective on the research you guys can conduct.
Yeah, I think more than anything, this has really launched us into a legitimate, field-capable research department.
Dr. Webb showed me all of the equipment used for the Jag ski, and then it was time to put the jag ski on the water and collect some data.
All right. You ready, I'm ready, baby. Wow, this thing does have a lot of power, though. A little more detail.
And the other part of using a jet ski that sort of makes sense is that when the conditions are bad, the data that we collect is really too noisy to make any sense of anyways. So the limitations on the data collection sort of match the limitation on when it's appropriate to use this anyways. But also, being a relatively small program, we don't have lots of staff, we don't have lots of technical assistance, and we don't have lots of experience in terms of maintaining a boat or even storing a boat. And having something like this is pretty manageable.
Civil engineering dates back to 4000 BC, when humans abandoned a nomadic existence and adapted a system for infrastructure. Fast forward to 2011, and the University of South Alabama's Civil Engineering Department is supporting the expansion of the Gulf Coast by supporting the structural support and progress for years to come. That's a wrap for this week's show. I'm your host, Bobby John Drinkard, and we'll see you next week on The Job.